How would you implement a database index and why is it slow to insert but fast to search? So let me tell you the answer. You could just tell a database index is a separate data structure that the database maintains alongside your table. Its job is to let you find rows quickly without scanning every single row in the table. The most common implementation of a database index is a B tree, which is a balanced tree structure. Imagine your table has a million users. Without an index, if I want to search for a user by email, the database starts at row 1 and checks every single row until it finds a match. That is O of n. It gets slower as your table grows. Now, with the B tree index on the email column, the database instead navigates the tree. Each node splits the data in half like a binary search. So instead of a million comparisons, I might only need 20. That's O of log n, incredibly fast even at massive scale. Now, why is it insert slow with an index? When you insert a new row, the database has to do two things instead of one. First, it writes the row to the table, then it has to update the index and find the right position in the B tree. Insert a new node and potentially rebalance the tree to keep it balanced. If you have 5 indices on a table, every insert updates 5 separate B trees. That is the cost. So the trade-off is indexes are a read optimization that come at the cost of write performance and storage space. In practice, I would implement an index in PostgreSQL like the following. I could just say create index idx underscore users underscore email, which is the name of the index, on users of email. And I would use a unique index for columns like email where duplicate should not exist. I could do create unique index name on users bracket email. I'll add indices on columns I frequently use in where clauses, join conditions, or order by. But I would not index every column. That would slow down all my inserts and waste disk space. So in short, an index is a B tree that trades write speed and storage for dramatically faster reads. You choose indexes based on your query patterns. So the key terms to use to show your depth in this answer is you need to mention B tree or balanced tree index. It shows that you actually know the actual data structure, not just the concept. Then you need to explain about the complexity O of n versus O of log of n with the help of a B tree, balanced tree. This is showing that you think in complexity exactly what the company would want. And then you are talking about the rebalancing that is required after the insert operation. So you are showing that the inserts are expensive and one insert triggers multiple index updates. So this shows amplification, and you have covered the indices, saying that you need to contain all the columns that the query needs in the join operation, in the where clause, in the order by. So these are the tips to answer this question.